Hi guys, this video is going to be an introduction to normally distributed data, which falls under the strand statistical analysis in the Year 12 HSC aspect of the Standard 2 Mathematics course. This video will specifically look at the first content dot point. The first content dot point states that students need to recognize a random variable that is normally distributed, justify their reasoning why, and draw an appropriate bell-shaped frequency distribution curve to represent it. The sub-dot point is that students need to identify that the mean and median are approximately equal for data arising from a random variable that is normally distributed. Let's begin. To begin, we need to understand what is normally distributed data. Previously, you may have dealt with positively skewed or negatively skewed data, whereas normally distributed data is simply data that is symmetrical or distributed around the mean. So in this case, the mean is going to be right here. The second thing you need to understand about normally distributed data is that generally it shares the same mean, median, and mode. This set of data here, the x-axis is what is ever being measured, and the y-axis is the frequency of this occurring. So here we have the frequency of about 150 occurring at 50 odd times. And then it is symmetrical about that mean. Normally distributed data is always bell-shaped. It is never going to be positively or negatively skewed. So let's take an example, look at an example of real-world normally distributed data. Blood pressure can be normally distributed, weight can be normally distributed, handspan measurement, and sepal width of flowers can be normally distributed. So let's take a look at an example with some actual data to look at. Here we've been given a data set 2, 3, 3, 4. This could refer to anything you like. I've tabulated this data for you. So we have a score of 2, 3, and 4, and we have the frequency at which this is occurring. So the score 2 occurs once, the score 3 occurs twice, and the score 4 occurs once. To prove if this is normally distributed, the first thing we can do is calculate the mean. The mean, as you should know, is equal to the average. And the average is given by this symbol here, x bar. X bar can be calculated by sigma x on n. This just means the summation of all x data points divided by how many data points there are. So x bar in this case is equal to 2 plus 3 plus 3 plus 4 divided by 4, which gives us an x bar of 3, a mean and an average of 3. For our data to be normally distributed, the median also needs to fall out to be the same as the mean. If we had ordered our data set, then we can find out that the median of this data set just by cancellation is also going to be equal to 3. So we're in the right direction for saying that our data is normally distributed. To definitely check though, we're going to also look at the mode. The mode is that is the most frequently occurring number. If we look at our data set, we can clearly see that 3 occurs twice, whereas 2 and 4 only occur once, making 3 our mode. To definitively state that our data is normally distributed, we can graph it into a histogram. So here's the histogram that I've roughly graphed up for you. So we have our scores along the x-axis, 1, 2, 3, 4, and 5. And we have our frequency along the y-axis, 1, 2, and 3. Our score of 2, as mentioned in the table, and our data only occurs once. Score of 3 occurs twice in our data set, and a score of 4 occurs once in our data set. You can clearly see that this is symmetrical about the mean, median, and mode, henceforth making it normally distributed data. So if we go back to our syllabus, we can say we need to recognize a randomly variable that is normally distributed. So a variable is randomly normally distributed if it is symmetrical about the mean, median, and mode. That is your justification. You can now draw an appropriate bell-shaped frequency distribution graph from tabulated data sets. And finally, the other content dot point that we needed to tick off was that we need to identify that the mean and the median are approximately equal for data arising from a random variable that is indeed normally distributed, which we have proven here.